Alright guys, so here is page 5 out of 8 for our quarter 3 review packet. We're going to go ahead and start off with number 19. We're dividing a synthetic, well it says using synthetic, but here we're dividing with a factor. Okay, so we can either do long division or synthetic, and in the video I'm only going to do synthetic division because I think that's the fastest and less complicated method. If you prefer long division, go ahead and find a previous video I've made or Mr. A has made for division of long division, or you can look it up on Khan Academy. We're just going to go ahead and do synthetic. First thing to check is to make sure we have every highest degree going down. So we have 3, the next one down should be 2, but the next one should be down is 1, which we don't have. So we are missing an x to the first power. So we have 0 x to the first power, and then our number. So now when I go ahead to set this up, okay, we take the coefficients, the numbers in front. So there's a 3 x to the third, a 7 x squared, we have 0 x to the first powers, and then we just have a constant that's 5. Then the number that goes out front, we take the x, we take our factor, set it equal to 0, and we get -1. So this is what we are going to actually be using for part of our synthetic division. Now the first step, if you remember, we bring it down. So we're going to go ahead and we are going to bring down the first number. In this case, it's 3, which is fine. And then we multiply. -1 times 3 is -3. And then you add going down. So 7 plus -3 is 4. And then we multiply. We repeat the process. -1 times 4 is -4, gets bumped in there. Add, we get -4. And then -1 times -4 is just 4. So let's see, 3, 2, 1, 0. And we have 3, -3, 7, 1, 2, 3. It is 4. That's -4. All right, so we actually get a remainder. So 5 plus 4 is 9. We actually, interesting, we end up with a remainder. So this is not divisible, which means we can't go ahead and factor, but doesn't mean we're stopping there. Once we've divided, we can go ahead and create it. So we started with x to the third. The next highest exponent down is x squared. So that's what this one starts off with. And then the next one down is x, and then that's our constant. So if I write the final answer, we have 3x squared plus 4x minus 4. And if you remember your remainder, we're going to do plus the remainder over the factor, x plus 1. So this is our answer once we finally divided. Okay, so sometimes it'll factor out, sometimes not. Now let's go ahead and do another synthetic division. It's the same thing. Check, we have 3, 2, 1 constant, so we're not missing anything. So when I go to set this up, I'm going to take the coefficient. So we have 3x to the thirds, we have a -2x squared, a 5x, and then a constant of -1. Take the x plus 2, set it equal to 0, we get -2. So -2 goes out front, and we always bring down the first number. Then we're going to go ahead and multiply. So when we multiply, we get -2 times 3, that's -6, and we add going down. -2 plus -6 is -8. Repeat. Sorry guys, I'm waiting for the video to catch up. Alright, I think it's caught up. So when we're repeating the process, we have -2 times -8. That is going to be positive 16. 5 plus 16. Alright, we get 21. negative 2 times 21 is negative 42. We get negative 43. Interesting. I don't know why I feel like I'm doing this wrong, but I'm not. So we have 3, 2, 1, that. 3, negative 2, 5, negative 1, negative 2. Bring down the 3, negative 6, negative 8. That's positive 16. 5 and 16, yep. Alright, so I guess this also didn't factor. I might have been wrong, but it doesn't look like it. So now our highest exponent was x to the third. Next one down is x squared, then an x, and then our number. So the final answer, another remainder, is 3x squared minus 8x plus 21. And we are adding our remainder on top, divided by our factor, x plus 2, that we tried to divide by. Okay. Next up, we are simplifying expressions, and we only want positive exponents, and only each letter show up once. So now I'm going to go ahead. I notice PEMDAS. We have 2x to the fourth, all of that raised to the third power. That means we distribute the exponent to everything, and that includes the 2. So this now becomes 2 to the third power, and x to the fourth raised to the third. That's when you multiply, so that becomes 4 times 3, which is 12, over 3. So this is now 2 times 2 times 2, which is 8, x to the 12th power, over 3. And 8 and 3 can't simplify any further, so that means we're done with this problem. The next one, 22, same thing. We have parentheses raised to an exponent, distribute it to everything. So this becomes x squared, and this becomes y to the 2 times 2, which is 4. All over x to the third, y to the negative 1. Now it says no negatives, and I just like moving my negatives. So I'm keeping the x squared and y to the fourth and x to the third. Right? Those are all positive, which means they don't need to move. But our y to the negative power, it's on the bottom, and if I want to make it positive, I just move it to the top now. So now it becomes y to the positive 1. Since I moved it, the negative now becomes positive. Next up, I can just combine any like terms. So I have x's there, and then I actually have y's here. So I'm going to do my x's first. So when you have x squared divided by x to the third, we're going to subtract our exponents. So 2 minus 3. Here's what we're going to do. 3 is on the bottom, and 3 is bigger. So I know my final answer is going to be on the bottom. Now I can just do 3 minus 2, and that's 1. So x to the first power is left on the bottom. Okay. Then I have y to the fourth times y to the first power. It's multiplication. They're both on top. We add the exponents, which becomes y to the fifth power. And we can stop there because there's only y there and an x there, nothing else, so we're done. The last two problems on this page, we are simplifying radical expressions. Again, assuming everything is positive. So here, it's a square root because there's no number, which means there's an invisible 2. So I'm going to go ahead and I'm going to break down 243. So let's see, any two numbers that multiply to give us 243, and that's 3 and 81. And 81 is 9 times 9. So there we are. We have 2 9s. I can pull out that 9. And the square root of 3 was left. If I want to do the same thing to x to the fifth, that's like saying how many groups of 2 do I have in the 5 x's. So 1, 2, 3, 4, 5. So I have a pair of x's, a pair of x's. I had 2 pairs of x's, so we can take out an x squared, but this x didn't have a pair, so it stayed inside. Then I can do the same thing with y to the 4th. If you wanted to, you could rewrite it as y to the 4 over 2, and that's y squared. Or if you wanted to, you could do 1, 2, 3, 4. We have a y there, pair of y's there. We had exactly 2 pairs of y's, nothing was left over. Now we can just combine anything on the outside, stays on the outside, and they go together. So we have a 9, we have an x squared, and we have a y squared, all on the outside. And then the square root, well, we had a 3 left over, and we had an x left over. The y's, everything came out, so we are done. There it is. So it helps if you take it out separately. Next problem. First thing you have to notice is that this is an index of 3. So here we had an index of 2, we looked for pairs. Here it's an index of 3, so we're looking for triplets. So 24, I'm going to break it down. 2 numbers that multiply to give us 24. That's going to be 4 and 6. That's 2 and 2, and that's 2 and 3. So look, I have triplets of 2, so I can take out a 2, but the 3 didn't have 2 other 3's. Remember, since it's an index of 3, I still have to keep that 3. Then I can do the same thing to the 8. So I have cube root of x to the 8th. I could rewrite it as 8 divided by 3, but we get a decimal. So if you wanted to, you could go 1, 2, 3, 4, 5, 6, 7, 8. We have 2 sets of triplets. So that means we can take out an x squared, but inside the cube root we have an x squared left over because they didn't have any buddies. Now I'm going to do y to the 6th divided by 3 because I can always rewrite this as inside divided by the index. And that actually, we don't get a decimal, we get y to the 2nd power. So just like here, if we wrote it out, all the y's perfectly come out because there are 2 sets of triplets in 6. So now our final answer, everything on the outside stays outside. So we have a 2, a y squared, and an x squared. And then don't forget, it's a cube root, so we still have to keep the 3. And a 3, then an x squared didn't have any triplet buddies, so they stayed inside. Okay, that wraps up page 5. If you have any questions, make sure you go check your teacher. Go ahead and try page 6. All right.